Now, I come to my last section of batteries, and frankly speaking, this charging of batteries, I will talk about charging batteries. I am going to discuss this in very brief as a part of batteries, because there is a full chapter, chapter 7, which of course comes after we discuss the motors in detail and battery pack design in detail, is going to get into depth on chargers. What are the chargers and charging infrastructure, but let me still get into what does simple charging of batteries imply. First important point that I want to make, I start with a diagram, and the diagram clearly shows two things: the voltage as the battery is charged and the current as the battery charged. Suppose there is a near empty battery at 0 hours. I told you typically take 3-4 hours to charge. This normally the battery is charged, and we will get into details of this later on, into in the early phase, in the first phase, first part of the battery charging from here to roughly 2 hours I have shown here, could be 2.5 hours. This is called constant current charging. Current is constant. You see, this is the current, this is the current, current is constant. Voltage of each cell and therefore the pack will start from small value. If it is a cell, it will start typically from 3.1 volt and will keep on going to maximum value 4.15. If it is a pack, it is the same 3.1 volt multiplied by number of cells in series and 4.15 multiplied by number of cells in series. The voltage will go and hit. So, normally it is almost fully charged. Well, it is not fully charged, battery is still not fully charged. You will see the percentage of charge is not still 100%. It will depend. It could be rate of depends on the rate of charging. You will see that it could be 80% charge, 90% charge, 95% charge, but still not be fully charged. And then you do very low rate charging. The current keeps on going down. You clamp the voltage. Initially, you clamp the current. Later on, you clamp the voltage. This is called constant current in the beginning, then constant voltage. You clamp the voltage and the small current will keep on flowing. As the maximum voltage reaches the charging voltage, you will see trickle current for a long time. So, only around 5 hours, here the battery is fully charged, no more current goes in. This is the way a battery is charged, and this is the best way of charging battery. This is also best way of preserving life of the battery. So, constant current, and constant current can be at 0.5 C, 0.2 C. Here it seems to be in 2 hours. So, closer to 0.5 C. This is constant current closer to 0.5 C. So, in about 2 hours it almost looks like it has reached, but does not reach, and then it is a constant voltage. You can charge of course faster. What happens when you charge faster? We will look at all these things. This is one method of charging. This is the better method, common method of charging. There is another method of charging, and that is you send a charging pulse. You send a large amount of current for a short period of time. So, not a constant current. What will happen when you put that large amount of current? Of course, if it is a large amount of current, suppose it is 1 C or 1.5 C, this is normally used for higher charging rates. When you try to charge at a high charging rate for the battery will tend to heat up. Why? Because heat will be dissipated. We will get into detail when we do thermal design of the battery, we will get into how much heat will be dissipated. Now, when it heats up, there is an internal resistance associated with the battery, and I square R losses will be there, that is a loss, but the electrical energy is getting converted into heat. Now, when it gets converted to heat, the battery temperature will keep on going up. As the battery temperature goes up, it will hurt the battery life. So, you need to stop. So, you create for a pulse and then you stop. You can, of course, there are two ways. One way is just wait for a period of time and then again give another positive pulse. Another is you put a small discharging pulse also. It has been shown that a small discharging pulse helps sometime the battery life. Even though the temperature does not go down so much, it helps. So, it is a small, very thin, very short time. It is like somewhat you are trying to get charge settled, very small. Then you again wait for some time, then you put a charging pulse. So, this is called pulse and burp charging. Particularly for fast charging, this has been found to be useful. Of course, this will have to be associated with cooling. You cannot do it without cooling. All right. So, essentially what does it mean? You have to put at a certain voltage a constant current or constant voltage. Here again you are putting constant current, then you are making current 0, then you are putting a large negative current.
But negative current also will result in positive heat, I squared.
Yeah, well, yeah, it will give different heat, but yes, it will also result in heat. So, it does not help in heat dissipation, it actually helps in charge settling down. Heat dissipation, there has to be cooling. This is done along with cooling.
This might be helping in the drop of voltage, so that next pulse.
Yeah. So, in fact, when you get into detail, you will see that it kind of helps settle down. We will come to the settling down later on. These are two methods that I gave you, but there are many methods. Constant voltage charging, that is commonly used for lead acid battery. Constant current charging, nickel cadmium batteries, just current remains. Now, how do you make the current constant? You have to design your charger to have a voltage which takes feedback. Voltage should be just above the voltage of the battery, so that a certain current flows. If the voltage of the battery starts increasing, the voltage for charging has to keep on increasing. But you have to keep on getting feedback such that a constant current flows. That is a very common way of doing this. You design a voltage source which keeps on changing by taking feedback of the current. So, it maintains the current. Taper current, that is used in sealed lead acid batteries. Pulsed charge, you charge, stop, charge. Negative pulse charge, I just show you. IUI, constant current followed by constant voltage, then equalize. There are various other techniques, constant current, constant voltage, and then you float, keep that at same voltage. There is a trickle charge, very slow charge, float charge, random charging. These are all different methods. Random charging, for example, is very important, for example, for regeneration. When you do a braking of the, then you are able to regenerate the electricity. The motor will go reverse and you will get a reverse electricity. I hope you will cover the regeneration, that is an important component of motor. So, that will give rise to a putting current back into the battery that you can't control. So, that is a charging which is random charging. These are more, we normally use constant voltage, constant current, constant current, constant voltage, constant current, constant voltage, and some amount of random burst charging, particularly for reverse charging. That is all that is used in electric vehicles for lithium-ion batteries. So, constant current followed by constant voltage charging commonly used. Now, electric vehicles will constantly communicate with charger. So, the vehicle has a battery, there is a charger, the two will be talking to each other. and saying no, 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 my current is becoming like this, and there is a communication protocol. There are messages sent, digital messages saying now increase, decrease, do not do that, I am heating up, do not do that, stop charging. All this is a part of communication protocols. This is a communication between battery and the charger. So, charger sets a charging voltage to maintain voltage and current, and changes charging voltage continuously to maintain constant current. For constant voltage, it just maintains the voltage. For constant current, it will continuously change the voltage to maintain constant current. Now, this communication also helps us to cut off when needed. Any time say a cell is getting heated up, BMS will constantly monitor cells. Any cell has got heated up, cut off. Enables varying the charging rate, saying now I can take more charging rate. Fast charging gets the voltage close to the peak cell voltage very quickly, much before battery is fully charged. And then it is a constant voltage charging, so that will take a long time to get it fully charged. Oh, I think it is not even shown, but in the next chapter, which I will straight away start, you will see all this charging. So, basically here I am saying lithium ion batteries, NMC and NCA dominates EV market today. R&D is bringing up new batteries with higher energy density, but some distance to go to match costs, life cycle, charge discharge rate, temperature performance, safety and stability, constantly evolving. Cost of battery is not just the initial capital cost, but also a function of life cycles, which itself depends on rate of charging discharging. Absolute charge discharge rate will depend on the battery size used, as well as the C rate will have to match vehicle power, need of the power. So, the C rate is not something that you can decide arbitrarily, particularly for discharge. Charging, you have little more on control. Discharging, whatever motor requires, you have to give. Temperature during charging discharging impacts the life cycles, depth of discharge used impacts the life cycle, and high interest rate in India makes the matter worse. Well, there are some assignment questions, these are mostly true and false, and I think I will stop with this for chapter 4. This is chapter 4 done.